Following the extinction of the dinosaurs and other ancient reptiles, mammals were beginning to gain a foothold on Earth, conquering the land and seas. During the Eocene epoch, a new order of mammals began to evolve, the carnivorans. Initially overshadowed by their larger relatives and the many hoofed predators that existed at the time, these animals would eventually diversify and rise from their humble beginnings into some of the largest and most dominant mammalian predators, withstanding the test of time. Among them was a family that predated modern-day bears and dogs, which gave rise to one of the Miocene's most magnificent hunters. This is Amphicyon, the ambiguous bear dog. The oldest record we have of Amphicyon being uncovered and described seems to be as far back as 1825, when the species A. giganteus was described by Heinrich Rudolf Schinz. On May 16, 1836, French geologist Alexandre Lemire requested a letter that had details of an exploitation in the Sanson paleontological site from French paleontologist Edouard Lartet, located at the department of Gers, France. Lartet had described several hoofed animals along with a mammalian carnivore that he named Amphicyon, based on the ancient Greek words amphi, meaning on both sides, and scion, meaning dog. This is due to the peculiar teeth found in the jawbones. The canines were described as resembling those of raccoons, while the molars in the first two tubercles were similar to dogs. Lartet also pointed out a third tubercle in the upper jaw, which is only known from bat-eared foxes. Initially, the name Amphicyon was a temporary classification until French anatomist Henri-Marie Ducrotay de Blainville sketched the fossils in 1841, recognizing two species, A. major, which would go on to become the type species, and A. minor. However, A. minor would eventually be reclassified into the genus Hemicyon, better known as the dog bear. In 1876, English naturalist and geologist Richard Lydekker described a new species of Amphicyon based on fossil findings from the Potwar Plateau in Pakistan, giving it the name A. paleoindicus. Following this, more Amphicyonid fossils would be found in Pakistan and Nepal and grouped into this species, though there has been some debate regarding such classification. In 1885, two more species, A. bohemicus and A. steinheimensis, were described by Fraz, both of which would then be moved to the genera Peludocyon and Heismanocyon respectively. In 1891, Kittel described the species A. gutmanni. Kuss considered it a subspecies of A. major, while Miklos Kretsoi reclassed it into the genus Hubasyon. Varanta, however, considered it a distinct species while arguing against the validity of Kretsoi's classification. In 1910, Henry Guy Elcock Pilgrim described a new species of Amphicyon from Pakistan as A. lydeckeri, only to then reclassify it as the genus Arctemphicyon, which caused a split among scientists regarding the correct classification, with some considering the new genus name as a junior synonym to A. lydeckeri. Pilgrim would then describe another species in 1932 called A. cooperi. In 1924, William Matthew described Amphicyon fossils from the Olcott Formation in Nebraska, giving the species the name Amphicyon ingens. In the same year, Matthew also described another American species, A. frendens, from the Sheep Creek Formation in Nebraska. In 1930, fossils of an Amphicyonid were uncovered in Germany and classified as A. epelscheimensis by Wetzel. However, there has been some debate among scientists as to whether this is actually a subspecies of A. major or simply synonymous with the latter. In 1939, A. tyrumensis was described by American paleontologist Edwin Harris Colbert based on fossils excavated from Inner Mongolia. In 1940, a specimen from Florida was described, being given the name A. intermedius by Dr. Theodore E. White. Following this description, White speculated that A. intermedius lived with another smaller species. However, it is now considered a dubious name and a junior synonym to the species A. longiramus, which was proposed by Stanley John Olson in 1960, after realizing that these two different bear dogs were merely a case of sexual dimorphism within one species. In 1950, A. diatrichi was described by Dem. In 1962, a new species, Amphicyon estri, was uncovered from early Miocene sites in France and described by Kuss. However, he later re-evaluated the classification and moved it to the genus Pseudocyon. It was then reassigned back into Amphicyon. In 1965, Kuss then reclassified A. giganteus as a new genus Megamphicyon due to dental differences between it and A. major. There has since been debate over this classification, with some scientists sticking with the original name by Shins, while others have been using Amphicyon as recently as 2020. In 1977, a new species, A. olissaponensis, was described by Antunes and Ginsberg following a mandible discovery in Portugal. Varanta reclassified it as Amphicyon due to differences between the specimen's teeth and those of other amphicyons. Much like with Giganteus, this has left paleontologists split on the correct classification. Simultaneously, A. carnuntens was described by Antunes and Ginsberg, initially as a subspecies of A. giganteus. Ginsberg would then describe another supposed subspecies in 1989, calling it A. giganteus lognacensis. When the classification was made invalid, Ginsberg proposed the species name A. lithanicus. Following this, Antunes and Ginsberg suggested that Pseudocyon sanseniensis should be reclassified as A. carnuntens with A. lithanicus as a synonym. In 1981, fossils found in Batallones 1, Madrid, Spain were classed as the species A. castellanus, only to then be reclassified as a separate genus, Megariscion, in 2008 by Stefane Pieni, Manuel J. Salesa, Jorge Morales, and Mauricio Anton. In 1985, a new Amphicyon specimen was discovered in the Danitz-Puszta sandpit in Pécs, Hungary, and described as the genus Hubascion by Kretzoy before being reclassified as A. panonicus. In 2002, fossilized footprints from the Barstow Formation in California, previously named Herpexipes alphi, were then redesignated as belonging to A. ingens. In 2003, the species A. galushii was described by Robert M. Hunt Jr. based on fossils found from the Troublesome Formation in Colorado and the Running Water Formation in Nebraska. In 2018, a new species, A. zhangzhenji, was uncovered in northern China, with it being considered a close relative to A. giganteus and the ancestor of A. lydeckeri. In 2022, a new paper was published reanalyzing several fossilized footprints from Ipolytarnog, Hungary. The footprints previously classed as Platycopus maxima are now believed to have belonged to Amphicyon major. After all these discoveries were made, Amphicyon would make a mark on prehistory as one of the most widely spread extinct mammals on the planet. Skeletons of Amphicyon show shared traits of canids, bears, and even feliforms, making the animal a chimera of sorts among carnivorans. A study done in 2010 of the animal's morphology showed more traits of felids and bears more so than canids. It had powerful limbs with plantigrade paws much like bears, and in stark contrast to some of their other relatives who possessed digitigrade feet like cats and dogs. Their most distinct feline-like trait would have been their heavy tail. The skull shape, however, has been compared to those of wolves and even spotted hyenas. Bear dogs also displayed sexual dimorphism, with males being larger and more robust than the females. Because of Amphicyon's massive plethora of species and wide range, this would have meant that this animal as a whole had a wide variety of different sizes. The smallest species was the early Amphicyon estuary, which had weighed at around 112 kilograms or 247 pounds. However, no specific length or height has been estimated for it yet. The Afro-Eurasian Amphicyon giganteus was among the larger members of the genus, with females weighing at around 157 kilograms or 346 pounds, while males weighed at approximately 317 kilograms or 698 pounds, with a length of 2.5 meters or 8 feet and a height of 1.4 meters or 4 feet. While A. giganteus was the largest of the Old World species, it was dwarfed by the North American Amphicyon ingens, which was the largest of all the Amphicyon species and Amphicyonids as a whole. It would have had a length of 2.5 meters or 8.2 feet, a height of 120 centimeters or 3.93 feet, and a weight of 200 to 550 kilograms or 441 to 1,212 pounds. While they only scratched the surface, these estimates show just how diverse the size range would have been for Amphicyon and all of its species that were found in their respective continents. Amphicyon belongs to a suborder of carnivorans known as Caniformia, which generally consists of mammals with dog-like traits such as elongated snouts and/or non-retractable claws. Modern-day representatives of this suborder would be canids, bears, seals and sea lions, raccoons, and mustelids, just to name a few. Amphicyon, however, doesn't belong to either of these modern-day groups. It was part of a long-extinct family of carnivorans known as Amphicyonidae and in the subfamily Amphicyonidae. While it's generally accepted by scientists that amphicyonids are rather distant from canids, several hypotheses have been made regarding the possibility of amphicyonids being a sister group to the bear family Ursidae, due to similarities in the structure of the skull and shoulder bones. This is, however, difficult to prove unless more primitive bear ancestors are found with similar traits to early amphicyonids, meaning that, as of our current understanding, these shared bone structures may simply be a case of convergent evolution. While the largest, Amphicyon, is not the sole representative of this family, however, as there are 4 more subfamilies that make up the bear dog lineage. These include Diphoninae, Haplocyonidae, Temnocyonidae, and Thaumastocyonidae. Some of them predate Amphicyon, such as Cynodictis, while others lived around the same time as the former, such as Megiroscion, Diphonodon, and Thaumastosion, just to name a few. Depending on genera, bear dogs varied in terms of morphology, with some taking on a more bear-like appearance, while others were similar to dogs. Some of the earliest genera, however, were relatively similar to civets. The evolutionary history of amphicyonids seems to have begun in the Middle Eocene epoch in North America. This is theorized in large part due to the high concentration of Eocene-dated bear dog fossils within the continent compared to those excavated from Europe and Asia, especially along the southern region of the United States, which is far from landmasses connecting North America to Eurasia. Initially, the North American genus Diphonus was believed to be the earliest amphicyonid until the reclassification of 2 Myakis species into the genera Gustafsonia and Engelarctocyon. These civet-like mammals are now believed to be primitive amphicyonids that predate Diphonus, with Gustafsonia being the oldest and potentially the ancestral genus. However, late Eocene findings from East Asia indicate that Eurasia may have been an important range from where early diversification of amphicyonids occurred. The reclassification of Gustafsonia and Engelarctocyon also brings about further discussion regarding the grouping of various carnivore forms within Myakis, as the genus has at least 19 species assigned to it, with the type species M. parvivorus being the only justifiable placement. It's been suspected that, historically speaking, it was a common occurrence for many primitive carnivore forms to be grouped into Myakis regardless of taxonomic evidence. As previously mentioned, Amphicyon in particular had multiple species making up the genus, with much debate regarding the validity of most of them, including various synonymous genera among some of its species. It's also been speculated that some of these recognized species may even be ancestral to one another, with A. asteri being considered the oldest species and ancestral to all subsequent others. The relatively young A. lydekeri or Arctemphicyon is believed to be a descendant of A. zhangzhenji, a close relative to A. giganteus. A. galushai was the earliest North American species known from the fossil record and is believed to be the ancestor of A. frendens, which in turn is speculated to have given rise to the massive A. ingens. From the early to late Miocene epoch, Amphicyon was a widespread predator during its time, being found in North America, Africa, Europe, and Asia, with the fossil record indicating a greater distribution of the animal in Europe especially, while fossils of the genus in Africa and Asia are quite rare. Scientists speculate that there were at least 3 different dispersals from Europe to Asia during the Miocene, which consisted of their eventual spread into North America, the rise of A. zhangzhenji, and then A. ulungurensis. Despite its prominence during this time, Amphicyon may have initially appeared far earlier, as fossils of the genus have apparently been excavated in Georgia, Germany, and Switzerland dating to the late Oligocene epoch. During this time of global warming, with temperatures far warmer than the preceding Oligocene epoch and the following Pliocene, the continent saw an increase of open plain habitats such as grasslands, deserts, and tundras, which in turn caused a decline of forested habitats. Some species of Amphicyon would have most likely made a home for themselves within these open plains. When it came down to the animals that existed with Amphicyon, while it generally varied by location, the most consistent seem to have included rhinos, horses, proboscideans, canids, and other amphicyonids. At the Sanson fossil site, several herbivorous fossils that were uncovered and described by Lartet include 3 proboscideans, which consisted of the mammutid Zygolophodon, the Gomphothere gomphotherium, and a species of Dinotherium or Prodinotherium. Along with them included several odd-toed ungulates such as the rhino-relative Hopaloaceratherium, initially classed as just a rhinoceros, and a horse relative called Anchitherium, which was previously classed as Paleotherium. Other animals described from this site include the Gomphothere archaeobelodon, the Calicothere anisodon, another bear dog called Sudscion, the dog bears Hamicyon and Plithoscion, the primates Pliopithecus and Plesiopliopithecus, and several felids including Pseudilurus and Stereophilus, just to name a few. In the Running Water Formation in Nebraska, fossils of A. galushae were found alongside fellow amphicyonids such as Cynellus and Diphonodon. The formation also consisted of various herbivorous and omnivorous mammals, including the Oreodonts Merychius and Merycochirus, early horse and rhino relatives such as Desmotypus, Diceratherium, and Menoceras, the prehistoric beaver Anchithyriomus, the Anthracotherium Aratatherium, and Hypertragulus, a member of an extinct family of even-toned ungulates called Hypertragulids. The fossil record for this formation also saw a high number of different canid genera. Most prominent of those belong to the subfamily Borophaginae, or bone-crushing dogs. These included Synarctoides, Desmoscion, Metadomarctus, and Tephrosion. Other canids included the Hesperocyonin Osbornodon and Leptocyon, the first true canine. The formation also contained fossils of carnivorans separate from amphicyonids and canids. These included a Daphocyon, a member of the raccoon family Procyonidae, and a mustelid called Cratorogale. At least 3 reptiles were uncovered in this formation, including a Miocene snapping turtle called Macrochelys schmidti, a worm lizard called Rhinura marsledensis, and a species of spiny lizard. At the John Day Formation in Oregon, A. galushae was also found alongside the Calicotherium meropus, along with the equine Parahippus. Other animals include the camelids Protolabus and Peritolopus. At the Karakeller Quarry in Turkey, fossils of other animals alongside A. giganteus included the rhino relatives Hispanotherium and Cimentodon, the giraffid Giraffachyrix, the horse relative Anchitherium, a Miocene musk deer called Micromyrix, another even-toed ungulate Triceramyrix, and a rodent Cynepospalix. Fossils of A. giganteus have also been found in Africa, primarily in Egypt and Namibia, where it lived with African gavialids, early crocodiles, monitor lizards, along with the hyenodonts Hyenailuros and Megistotherium. A fellow amphicyonid, Namibiocyon, was also found in Namibia with A. giganteus, along with other carnivorans such as the early felid Diamantophilus and various prehistoric mustelids and vivirids such as Africanictus and Orangictus. Surprisingly, another animal excavated from Namibia was a rhino species in the genus Diceros, of which the modern-day black rhinoceros belongs to. At the Hujialang Formation in Gansu, China, both A. zhangzhenji and A. tyrumensis were found alongside the Gomphotheres Gomphotherium and Platybelodon, along with the primate Pliopithecus, the hyena-like Percrocuta, and the dog-bear Plithocyon. Fossils of the type species A. major have also been found in Los Veles de Fuenteduena, Spain, alongside 2 other amphicyonids, Megirocyon and Thaumastocyon, along with early hyenas, bears, Eomelivora, a honey badger relative, and 2 species of the saber-toothed cat Machairodus. Potential prey animals included the Gomphothere Tetralophodon, Dinotherium, a rhino relative Aceratherium, a giraffid Dicenotherium, the equine Hippotherium, and musk deer Micromyrix and Hispanomyrix. While these only scratch the surface, it may be safe to assume that a large number of Miocene fauna from North America and Afro-Eurasia would have likely encountered Amphicyon, if not one of its many relatives. Amphicyon's behavior, diet, and hunting methods have long been the subject of discussion. Much like bears and most big cats, bear dogs are believed to be predominantly solitary animals, with males mating with multiple females. Several fossilized burrows from Nebraska especially may even indicate denning or burrowing behavior among bear dogs in the same vein as modern-day bears and canids. Various analyses of Amphicyon's diet seems to indicate a varied one depending on the species. While generally accepted to have meat in their diet, with teeth especially useful for crushing bones, discussions however arose on whether they're strict carnivores or if they had more of an omnivorous diet. An analysis on the molars of A. longiramus and fellow bear dog Ishirocyon indicated a highly carnivorous diet due to a lower relative grinding rate compared to the brown bear. However, other studies suggest that the North American species may have been omnivorous after all. Another study suggests that A. major was mesocarnivorous in the same vein as red foxes, meaning that they would have predominantly eaten meat but also have the occasional plant-based matter. A study from 2020 based on findings from Bosnia and Herzegovina indicates that A. giganteus may not have been a strict carnivore. Amphicyon would have fed on a varying degree of ungulates ranging from early deer, horses, and rhinos, just to name a few. Several Miocene-dated fossils, including those of rhinoceratids like Iberotherium and Procentaurinus, have been found with bite marks that are believed to be inflicted by amphicyons, though there has been some debate as to whether this was a result of hunting or scavenging. Paleontologists have speculated that Amphicyon would have been an ambush predator in the same manner as modern-day big cats. However, one study suggested that because of differences in Amphicyon's forelimbs compared to lions and tigers, it may have struggled to hunt in a similar way. However, said study also mentioned that upon catching their prey, Amphicyon would use its powerful forelimbs to grab hold and subdue them, but may not have killed them with a directed bite due to their skull shape. Because of a similar shape to wolves and hyenas, it's possible that bear dogs may have eaten their prey alive instead. Since its discovery, Amphicyon has appeared in its fair share of documentaries. Its first appearance was in the 2009 documentary series Prehistoric Predators. While it had no dedicated episodes, it was featured prominently in the episodes Razor Jaws and Hell Pig, which covered Hyenodon and the Entelodons respectively. In the following year, Amphicyon was featured in its own dedicated episode of Monsters Resurrected or Mega Beasts. In the same year, Amphicyon also appeared in episode 3 Washington DC of the series Prehistoric. Not to mention that during some point in the future, Amphicyon is said to appear in an internet documentary series titled Forgotten Bloodlines Agate. As for games, Amphicyon only has 4 appearances. These games include Jurassic Park Builder, which added Amphicyon in the Glacier update as a limited-time creature. Another game Amphicyon appears in is Jurassic World the Game, where it was added on April 19, 2017 as part of the Cenozoic Park. Jurassic World Alive added Amphicyon in Update 2.3 on November 27, 2020 as a common creature. Finally, the last game Amphicyon makes an appearance in is the mobile game Dinosaur Park Primeval Zoo, which came out on February 2, 2021, where it can be added to a forest biome enclosure with up to 8 members in its exhibit. While Amphicyon has had its fair share of media appearances, hopefully in the future this amazing animal will star in even more paleo documentaries or games. Amphicyon and the rest of its relatives began to disappear around the late Miocene epoch, with the North American genera disappearing around 9 million years ago. Most of the European genera also disappeared roughly around the same time, likely due to the Vesalian Age crisis, in which a vast majority of Middle Miocene fauna disappeared following the decline of forested habitats and the spread of open plains in the continent. Amphicyon persisted perhaps the longest in Asia, possibly into the early Pliocene, according to fossils of A. Lydekeri or Arctamphicyon in the Padwar Plateau in Pakistan. Supposed Pliocene-dated fossils of Amphicyon in the Kazyakin Quarry in Stavropol, Russia, may indicate that the genus also persisted far longer in Europe than the rest of its relatives. Other sources also state that the family persisted the longest in Africa, with genera such as Afrocyon and Bonicicyon before finally going extinct. The exact causes of the family's extinction aren't quite clear and may have depended on the distribution of the genera or species. These may include factors such as climate change, extinction of their usual prey, and/or competition from other predators. Some fossils have revealed that several amphicyonids dealt with delayed tooth eruptions in which juveniles would still maintain their milk teeth and struggle to properly process food for approximately 2 to 3 years of age. This may have also contributed to the family's eventual disappearance. The Pliocene epoch, a precursor to the Pleistocene Ice Age, began around 5.3 million years ago and saw an era of global cooling as the landscapes became colder and drier. This epoch saw the disappearance of several ancient lineages that coexisted with bear dogs, along with the persistence of others and the emergence of more modern-day genera and species, especially among fellow carnivorans such as the brown hyena, jackals, and sloth bears, just to name a few. The most well-known evolutionary event of the Pliocene, however, was the emergence of the genus Homo, which would go on to dominate the planet in the following Pleistocene and Holocene epochs. Amphicyon was an enigma from a bygone age, flourishing at a time when its fellow carnivorans began gaining a foothold on Earth, becoming the dominant predators in many of their respective ecosystems. It's an animal with much uncertainty, from how many species truly belong to this genus, and to especially how it went extinct. Hopefully in the near future, we will further unravel the mysteries of Amphicyon, the ambiguous bear dog. Thank you all so much for watching today's video. We put a lot of work into this one and hope you enjoyed as much as we did. This video was certainly an experience to make. This video was directed and narrated by myself, RangoGamer. It was scripted by myself along with the CrimsonAcro and the Primal Earth. It was edited by myself, the Primal Earth, LegitEliminator, CrimsonAcro, MikeMC9797, and SpinoDragon Productions. Animations for A-3 and Giganteus were done by Mephilas Seijin101, and the animation for A-Ingens was done by TheDinosaurHunter. And lastly, the research was done by myself, SpinoDragon Productions, and the CrimsonAcro. And as always, see you all next time on Epoch Now.